Alright, so the problem is best time to buy and sell stock. So in the problem statement, we are given an array of integers named as prices of size n, and their price I specifies that it is the price of a given stock on the ith day. Alright, so we need to maximize the profit by choosing a single day to buy a stock and a different day to sell that stock. Now we need to note that you can't sell a stock before you buy one, which means that if you are purchasing a stock on day I, then you cannot sell it before I. Means you need to purchase at I and you can sell at I plus 1, I plus X day, and we need to return the maximum profit that we can achieve from this transaction. Alright, so let us consider this example. Input, we are given prices array. So this is the prices array, which means that we need to maximize the profit. Now how to deal with this question? Suppose I purchased an item 7. Now I can sell an item following this item, not before, which means that, for example, if I select ith item number 1 for example, then I can select the elements following this, not the elements before this. Alright, so let us consider, for example, I purchase an item number 7. Now I can sell it at profit 1, so at price 1. So the profit will be 1 minus 7, that is minus 6, which is not maximum. Then considering the case of purchasing at 7 and selling at 5, we are at negative profit. Following this, we have 7 and 4, 7 and 3, 7 and 6. Nowhere we are getting maximum profit. Now consider all cases with 1. Purchasing at 1, selling at 5, we have a profit of 4. Consider next case 1 and 4. Purchasing at 1, selling at 4, we have a profit of 3, but it is not maximum, we have a maximum profit of 4. Consider the case 1 and 3, we have profit 2, which is less than 4. 1 and 6 finally, which gives the profit 5, which is the maximum profit. Now consider all cases with 5. 5 and 4 not possible, 5 and 3 not possible, 5 and 6 is 1 profit, which is less than 5. Consider all cases with 4. 4 and 3 not possible, 4 and 6 2 less than 5. Considering the cases with 3, 3 and 6, that profit is 3, which is again not less than 5, so not possible. So after considering all cases, we get that the maximum profit will be 5 when we purchase at 1 and sell it at 6. So there are various ways of approaching this problem. First, we are going to consider the naive approach. So the way I explained, we are going to iterate over all the elements in the array and find the maximum profit. So we will have an outer loop that will start from 0 to n minus 1, and inner loop that will start from 1 to n. And we are going to compare the profit every time by subtracting the values, and the maximum value would be the maximum of all, the way we discussed. But that gives a time complexity of order n square, so that is not possible. This question can be solved using a greedy approach. So greedy approach, we need to consider having maximum profit, which can be achieved by having purchasing at a minimum rate and selling at a maximum rate. So the way we are going to approach it in a greedy way is, Let us consider, I'm gonna start with my maximum profit as 0 and purchasing amount as 7. Now I'll consider the next elements. Suppose element 1. Now I'll compare these two elements. If 7 is greater than 1, I am going to purchase it at a price less than 7, which is 1 in this case. So my purchase amount will be 1. Again, moving forward, 1 is less than 5? No. So in that case, we are going to check the maximum profit. For example, here, if current price, that is 5, minus the purchased value, that is 1, if this is greater than your maximum profit, that is 0, then this value will be your maximum profit. Let us write a code for this to better understand. Suppose I declare a variable purchase which initially points to prices of 0, and I have a maximum profit of 0 initially. I'm gonna start with elements 1 to n, and every time I'm going to compare if the purchasing amount is greater than the next value, I am going to purchase it at a smaller value, that is prices of I. If my purchasing amount is already less than the next amount, in that case I am going to check if the profit, that is current element minus my purchased amount, is greater than my maximum profit. So I'll set my maximum profit as prices of I minus purchase. And finally, we need to return the maximum profit. Let us run and check. Oh, I have some runtime error. Oh, sorry. So n is not defined. Let me define n as equal to length of prices. Alright. Let us try once again. Okay, so my bad. It's I. Alright, let us try to submit. Yeah, it passes all the test cases. So this approach is known as greedy approach.